Okay, we ended on the slide, but I didn't get totally through it. And there's only 2 slides left, so that's why we're going to make this really short, but we'll put it all in one. Okay, so again, oxal acids is anytime you have hydrogen, oxygen, and one other element. It could be sulfur, like sulfuric acid. It could be nitrogen, like nitric acid. Um, if it's NO3, HNO3, it's nitric acid. If it's HNO2, it's nitrous acid. You know, they have some version of that. And again, if you want to know the rules, I gave you a sheet, the very first part of this chapter that goes through all the acids, and you can see the method or how to name them. I didn't give you a process of naming them because you can just look them up, okay? But again, here's some. We have hypochlorous, hypobromic, hypoiodic, and then they have the higher their electronegativity, usually that increases as the nonmetal electronegativity increases, for the acidity increases. If you look here, here's chlorine. Okay, it has a much higher number, so it has a higher dissociate constant. And again, remember, if it's -14, that's much lower than -8 because these are negative numbers. So this would be the one that has the highest constant and so on down the line. And these are the ones with the highest electronegativity. So again, it's when we're looking at these numbers, how well do they break down into their ions? That's what they mean by disassociating. Okay, we got one more slide. Okay. All right. So if an element can form more than one oxal acid, the oxal acid with the more oxygen atoms is the more acidic. Okay, so sulfuric is excuse me, H2SO4. Sulfurous is H2SO3. So sulfuric, because it has more oxygen atoms, would be the one that becomes more acidic, that has a lower pH. Okay, here they have hypochlorous, which is HCl. There's just one oxygen. Now we add another oxygen for chlorous. Then we have chloric, where we have 3, and now we have perchloric, where we have 4. So this is going to be the strongest acid. This is going to be the weakest acid. Okay, and you can see the increase with their case of thing. So when you're looking at oxal acids, and again, there's many of them. You have, you know, again, hypochlorous, then we just have chlorous, and then we have chloric. These are all acids. Hypochlorous acid, chloric acid, perchloric acid. But again, each time we're just adding an oxygen. This would be the strongest one. This would be the weakest one. Okay, so again, there's little patterns. Another way of saying it is the oxidation number increases then, because the oxidation number of oxygen here would be -2. Here it's -3, and so on and so forth. But not a big deal. Just wanted to show you what happens because we've got a lot of acids where you just add one more oxygen onto them. Okay, and again, those are oxal acids. So you have hydrogen and the halogens, hydrochloric, hydrobromic, hydrofluoric, and then you have hydrogen, oxygen, and another element, and that depends on what the other element is. Okay, so those are your acids, and so we're done with chapter 16. We're going to work some more on those Rice tables, trying to determine like case of A or case of B and what their pH is. Okay, and that's it for chapter 16.